Hello everyone, we will continue talking about the comparing the means, and the second topic is one sample t-test. So now we will check the test. This is one sample, so we have one sample in not two like before. We have one, and we want to check the score if it is different from a value, any value that we decide on. So let's think about that we have the population for the whole school, and we have the sample is the two classes that we had previously. So we want to check is the score mean for all students in the school is different from 75, and our sample is the two classes that we have. So we cannot get all the score for all the students in the school. We only take our sample, which is this two classes. We want to check if it is different from 72. First, okay, what is the test variable? Is the student score, and what is the value that we want to test, if it is different from it or not, 75. So now we have the hypothesis. The first hypothesis, this is the mu1 is the population mean. So the mu1 is equal to 75. There's no significant differences between the population mean and the tested value. This is the population mean and the tested value. There's no significant significant differences. The second hypothesis, there is significant differences between the population mean and the tested value, but we are testing in the two direction, so we don't know. There's difference, but the difference is that is it more or less, we don't know, but we know that it is different from the tested value. Sometimes we want to check if it is higher than 75. We check it if it is higher than 75. In other situation, we check if it is less than 75 to know. But here in this example, we only check if it is different than 75. We can write this down. If the significant value is equal or less than 0.05, less than 5%, then we accept the alternative hypothesis. Okay, now we open the class mean again. Go to view PASW. We choose type in data. Then we go to compare means one sample t-test. They are required to open the data file. We go to data example that we already had, class means. Now we open the sample that we have for the two classes. We want to check if this, regardless of this classification, we want to check if this column is different from 75. We go to compare means one sample t-test. We have this. It didn't show me the other variable. We go here, the test. What is the test value? Is it 0? No, in our case is 75. The confidence interval is important here, because as I said in the previous video, it's mathematically is not or we can't say like this. like it could be more or less, but as a statistical view, we could say that it is equal the population mean or not. So continue. Okay, these are the results. One sample statistics. The whole population, the whole sample that we had, the sample statistics, one sample, it's called, it's one sample, not two. So we check in this one. So here the t value, the t actual value, it's minus 1.2. The degree of freedom, which is n minus 1, 22 minus 1. And here's a significant for two-tailed, as I said, it's two-tailed. It's not more or less, it's more or less together. It is 0.2, and this value is more than 0.05. so we cannot reject the H0 hypothesis. So it means we are taking the H0 hypothesis, which is the first hypothesis, and the population mean is equal the 75 tested value. This is the tested value. So if we go to the hypothesis again, our results show that we had to take this hypothesis, that is mu is equal to 75. There's no difference between the significant difference between the population mean. There is a difference, but it's not significant difference between the population mean and the tested value. Okay, what is the population mean that we had? We don't know, but we know the population, the sample mean. The sample mean is, as we saw in the previous video, it was 73, and we can see the differences, the mean difference between the 75 and the sample, not the population, the sample mean is minus 2.3. So 2.3, 75 minus 2.3 is 72 point almost 6 approximately. So 70, let's say 73. So it's not, there's no significant difference, not important. The difference is not important. Okay, here's the confidence interval for the differences. It range from -6 to 1.5. Okay, let's suppose we have this, the significant tail is 0. What does it mean? If it is, this is 0 or less than 0.05, it means that the population mean is different. Whenever we see 0, it means that there's differences, like it might be like significant difference, not only difference, significant difference. It might be 95, the population sample, the sample value, the sample average value mean, it is 95, and we are testing for 75. So the sample is showing very big differences between. So we can see this sign here, this value can be 0 in this case. And normally, like most of the times in statistics, statistical analysis, we check for the analysis to be there's differences to be different from the population. So most of the times we want this significant level to be 0, so that we can find there's a real difference. Maybe we are checking for a new way of teaching, so yes, there's a differences in the new way, or the new way can get the students to understand more. So we are looking for the test to be significantly different. Now we finish for this part. Next part we will talk about the independent sample t-test. See you.